Welcome back to Homework Help with Miss Gore. Today we're going to be talking about Unit 8, Day 1. We are factoring with a greatest common factor. So what I'm doing is I'm looking for a number or a letter that goes into each piece of my expression. So what I can do is I can use what's called the box method. So in my box method, I'm going to take my 3x to the 5th, my 6x to the 6th, my 9x to the 7th, and I am going to put them in boxes, hence the box method. So what I'm looking for is what goes into all three of these pieces. So I notice that 3 goes into a 3, a 6, and a 9. So I have a 3, and I'm looking at my variables. I have an x to the 5th, an x to the 6th, an x to the 7th. They all have an x to the 5th. So now I'm going to divide. I'm doing reverse box method essentially. So I've got a 1 here, I've got a 2x here, and I've got a negative 3x squared here. So my answer is 3x to the 5th times 1 plus 2x minus 3x squared. And remember, we can always remultiply to double check if we are correct. I'm going to take a look at number 3. In number 3, again, I'm looking at all three of my terms, and I'm asking myself, is there a number that they all have in common, a factor? Is there a letter that they all have in common? And in fact, there is not. So this expression is considered a prime expression. Okay, let's skip down to number 5. Okay, so number 5, again, I can use my box method. So I've got my 3xy, and my 12xy squared. And I'm asking myself, what factor do they share? Well, they share a 3. Did they share any letters? Did they share an x? And did they share anything else? They share a y. So now I'm going to divide that out. So I have a 1. 1 times 3xy would give me 3xy and a 4y. So my solution, my factored form of my expression, is 3xy times 1 plus 4y. Let's take a look at number 7. So I'm looking at 7, and I'm trying to look again for my pattern. Is there a number or a letter that goes into all of my terms? So I have an x to the 4th, an x, 5x squared, an 8x squared, and a 15. And I'm trying to figure out, is there anything that goes into all 4 of those pieces? So I first think about, okay, well, what if I were to make this into a box here? Is there something that I could pull out of all 4 of those pieces? And with a quick glance, I'm seeing that no, there's nothing that's going to go into all of those pieces. So I'm going to try something else. I'm going to try a 2x2 box. In my 2x2 box, I'm going to put an x to the 4th, my highest power in the left, my 15 in the bottom right, and my 5x squared and my 8x squared. Doesn't really matter where they go. And I'm going to, again, try to look for a pattern. So I'm thinking, all right, well, how could I get an x squared, an x to the 4th? Well, maybe that's an x squared. Well, if that's an x squared, then this is an x squared. Okay, so far so good. And if this is a 5x squared, then that must have been a 5. Great. Now, to get a 15 down here, this number would have to be 3. Uh-oh. If I do 3 times x squared, do I get an 8? Sure don't. So this is also a prime term. Okay. Skipping down to number 9. Okay, so using my box method, okay, I might just want to box up my whole question. Looking for a common factor. So common factor between 12, 4, and 8 is going to give me a 4. And I'm going to do this one backwards. Why not? There's a 4. They have an A in common. They have a B in common. So now I'm dividing this out. So here I've got a 3, a B to the 4th. I've got an A to the 4th B, and a 2. So my answer for AB times 3AB to the 4th plus A to the 4th B plus 2 is my factored form. All right, let's jump down to number 13. In number 13, I'm looking for a recursive rule for the infinite sequence. So the first thing I have to decide is there a common difference or is there a common ratio? So I'm trying to assess what is the pattern here. So I'm going from -4 to 6 to 16 to 26 to 36, and I decide that this pattern is an adding pattern. I am adding 10 to get from one term to the next term. That's going to tell me that this is an arithmetic sequence. So remember, with an arithmetic sequence, I'm going to start with my a sub 1 term. My a sub 1 term is -4. My a sub n term. So how do I get my next term? Well, I've got to take my previous term, and in this case, I'm adding 10 each time. And that is my recursive rule. Have a great day.